All right, so where we left off yesterday, we were looking at the VBA language, and so what we're going to do now is look at what are called subroutines or sometimes macros. And so what distinguishes these from functions is that they can have any number of inputs and they can produce any number of outputs. But of course, they're executed differently than functions. And so there's advantages and disadvantages to both subroutines and functions. But the interesting thing about this is that in VBA, at least, you can combine both of these into the same program. You can have a subroutine that calls on functions. You can have a function that calls on subroutines. You can have any combination of both. It can get very, very complicated, but then there are rules that we have to follow. And we'll see some of these as we go along. There will be some programs where there's some subtasks, I guess you could call them, that really need to be done separately in order for the program to avoid becoming too terribly complicated. What you're basically doing is delegating some of the tasks to either other functions or subroutines. So the language is very, very flexible. You just have to be very careful. For example, you have to make sure you don't use the same variable name for two different things, which could happen if you're not careful, but there are ways we can safeguard against that too. So right now, we're just going to focus our attention on basic standard subroutines or macros that are not horribly complicated, just to get a feel for how they work. But eventually, we'll write programs that need the ability to split off and create other functions as we need them. Okay, so as we've already seen, if you go look at your spreadsheets, VBA code examples, remember, don't forget to install this developer tab. And so here under macros, you can see here's a list of all the ones that are attached to the spreadsheet. So we can run any one of these just by clicking it on and running it. Like, for example, array fill, we don't know what that is, but it works. Okay. So what we would like to do here instead is look at the VBA editor and examine these subroutines and try to understand what exactly they're doing. Okay. I'm going to turn off the intermediate window. We don't need that right now. So anyway, by the way, sometimes there can be subtle differences between the PC and the Mac versions. This is, as you know, a PC that I'm using. You should let me know if you have any issues with your Mac, so I can find out if there's something that we need to know about how this is done in the Mac. But as far as I know, they're similar enough to each other. You shouldn't really have any problems. That wasn't always true, by the way. There was a time somewhere along the way, I should remember it was the year 2011. That stuck out of my memory. Microsoft, for whatever reason, decided that they needed to hustle out the newest version of Office. It had been a while since the previous version, and they're feeling the heat. And so what they basically did was they released a version that was full of bugs. It was just a nightmare for them. And in fact, it got so bad that if you called Microsoft, the minute you called them, they would immediately ask you if you wanted a refund for Office 2011. They didn't even want to know what you were asking about. They were just like, do you need a refund? So among the many stupid things they did in that version was they actually took VBA out of Office for the Mac, completely ripped it out. And then eventually they did put it back after all the people complained about it. But they that was a tough time in VBA's history. So now the two are more or less compatible with each other. But there was that time when things were going badly. And even to this day, Microsoft, if you look down at my screen here, I have this function called math type, which I use continuously when I write notes for a course like this. And is an outstanding professional math editor, which you could use to write academic papers, for example. And it has the ability to create LaTeX, if you've ever heard of that. But once upon a time, this actually was included with Word and PowerPoint. It was actually part of the Office package. And then somewhere along the way, Microsoft decided, you know what? Why do we need these guys? Why don't we create our own equation editor? And the one that they have right now is just it's nowhere near as good as this one. So you actually have to buy it. The only problem is somewhere along the way, Apple stopped supporting this. So now if you have a Mac, you can't use MathType at all. You have to search around for something else. So, we do have to pay attention to compatibility issues between PCs and Macs. You never know when there might be problems. Anyway, enough of that nonsense. Um, so here we go. And as I just showed you, you can execute a macro once it's already been created by simply going to the macro box and hitting run. There's other things you can do too. You can actually create, we'll see it later on, you can create a little button on your spreadsheet that will actually let you click the button and execute the macros if for some reason that saves you a lot of time. There's a lot of ways we can do this. So anyway, if you recall, we've already done a sales tax program. That was, let's go back and revisit. I forgot which one it is. Oh, here it is. It was number 4. Okay. So here we executed this function as a function. Okay. So the sales tax program here was executed as a function. Recall what we had to do to execute it was, because it's a function, we're going to go here and we're going to type equals sales tax. And by the way, since it's in our list of functions, we might as well just click it on. And then now here's where it gets a little awkward. You have to remember what comes first. Here we put the retail price and then the sales tax rate. So I'll put 100, comma, 0.08, and we end up with a sales tax of $8. So what we'd like to do now is see how this could be done as a macro. Okay, the same exact function, the same exact routine, except as a macro or subroutine. What would be different? Okay, well, first of all, if you notice here, these values are being what we call passed to the program. In other words, when we call the function, we're saying, by the way, here's the information that you'll need to execute this function: the price, the retail price, and the sales tax rate. If you don't put those in, you're going to get something wrong. Although I believe if you leave those out, it might default to zeros, but it might also simply refuse to run. Let me just try that as an experiment. Oops. I'm just going to put nothing and see how it reacts. No, it doesn't like that. Okay. If you get them backwards, it'll run, but you'll get the wrong answer. Okay, because well, actually, no, in this case, that's not true because they're just being multiplied anyway. But usually, if you get the order of these values that you're sending to the program backwards, of course, you'd have to expect to get the wrong answer. Also, by the way, the values that are being sent to the program have a special name in computer science. It's hard to believe, but they're known as arguments. Okay, those are the arguments being sent to the function. So these are the values that it needs to execute whatever the program happens to be. And when it's done, if you notice, it also produces a single number. And we have actually a couple of ways of sending these arguments to our function. What we could have done is put the information on the spreadsheet. And then instead of sending the function the actual numbers, what we can do instead is send it the values. In other words, I'm sorry, the cell references is what they're called. So I would put B3 and then B4 because this is where the information is found. The advantage of doing it this way is that I can easily make a change and it automatically updates itself. Now, with a subroutine or macro, it doesn't quite work this way. So what would be different here? First of all, we use the keyword sub. Okay, sub is how it knows that it's not a function, but a subroutine or macro. So let's get that one open, number 5. Here it is right here. Okay, so sub. What else is different? Now here, if you notice, we're telling the program that these variables that we'll be using, tax rate, purchase, and sales tax, are single precision variables. Okay. That wasn't necessary. If we left that out, it would basically assign them to be variant variables, which means it would take up more space, but it would work. But as good programming practice, you really should get into the habit of identifying all the variables with the appropriate type so that there's no doubt in your mind what you're doing here. Also, it helps prevents errors because if, let's say that you try to assign to tax rate a letter or something like that, then it will give you an error message. You won't be able to accidentally do something like that. Now, these are constants here. You can define these right in the body of the program. In fact, in a case like this, you have to, because if you notice right here, there are no arguments. It doesn't accept them. With a function, the arguments are specifically shown right here. So it's saying, listen, you have to give me the retail price and the sales tax rate in order for this to work. Here, it's written with open and closed parentheses. The information will be read into it in another way. Okay. And so that usually that way is to put the information directly on the spreadsheet and then find it. Okay. So we're going to, here what we're doing is basically just saying, all right, the purchase is 100, the tax rate is 0.05. Now, by doing it this way, we can't change it like we could here. Okay, so that's kind of a disadvantage. I could instead have given it cell references. Although when you do give cell references like this, we have to be careful about the way we do it. Then this is what it's actually doing. Sales tax is the purchase times the tax rate. Now, if you notice too, when we're doing this as a function, the name of the function has to equal, or whatever calculation you're doing here, this name has to match the name of the function. That's how it knows that this is what needs to be sent back to Excel. Here, you don't have to worry about that. Okay, if you notice here, the subroutine is called compute sales tax, but the variable that we're calculating is called just plain old sales tax. So here we're using this interesting device that VBA has. It's called message box. So rather than printing this on the spreadsheet, it'll be like a little pop-up. Sales tax equals, in quotes, that'll be the string variable that will be appearing in this message box. This ampersand is used to tell it that both of these will go into the message box. In other words, this string and the results of this calculation. And then, of course, at the end, you must have end sub, although when you start writing this program in VBA, it will fill that in for you once it realizes that you're working on a subroutine. So let's run this thing and see what happens. All right, so this is just exactly what we were looking at. Actually, oh, I see what I did. I commented this out so you can see what happens under different assumptions. Actually, I'm glad that I did this because I want you to see a couple of different ways that you can express this information. So first, now it actually matches what's in the slides. So let's run it. How do we do that? We go back to the spreadsheet and ask it for the macro sales tax or compute sales tax. Now that's the message box. That's telling you, oh, your sales tax is 5. Now, if you don't want that, if you want it to go right into your spreadsheet, what you could do is use the following 2 commands. You just copy these. I know it may be hard to see this. I don't think there's any way of making this any bigger. So range, now you notice how it says A1 refers to this cell. It's in quotes. It has to be in quotes. And what this is saying is that we're going to take the value, apply a value to this cell, A1, which is literally the words sales tax. And then in B1, right here, it's going to actually put the result of your calculation, sales tax. Okay. Now it's going to override whatever's here. Okay. I don't have to bother deleting these, I guess. I could, but let's just see what happens when I just run this thing. Hold on. Here we go. Yeah, so whatever was there, it just goes through and it says, all right, you want A1 to say sales tax, B to be um, the sales tax, the actual calculation. Now, if I need more space, like here, for example, I can write this as A1 through, let's say, B1, and then I could put this in C1. Okay, let's see how that works out differently. So yes, it didn't do exactly what I thought. It just repeated it twice. Okay, so in other words, by it interprets this to mean I want to put the word sales tax in both A1 and B1. If you want to split it up over the two cells, you have to run it differently. You have to tell it to put cells in A1 and tax in B1. Okay, which you certainly could do. Um, and then, so let's get that out of here. This one, we want the sales tax in B1. And there it is. All right, let's just run it again. Yeah, and oh, this is still left over. Okay. All right. Now, there's many different ways of printing out your results on the spreadsheet. This is just one of them. Okay, it's a very straightforward way, but it's by far not the only one. There's many, many ways of doing just about everything in VBA. Okay, it's very, very flexible to say the least. It's not crazy powerful like some of the other languages, but it's very flexible. All right, so this is our first example of a subroutine or macro. So basically, if you have a lot of output, then you should probably use a subroutine or macro. If you only have one output, then maybe a function is the way to go. So anyway, let's look at some more examples of this. Okay. So I already discussed with you the idea of comments. Anything you see in there that's green is a comment. I here, like for example, I didn't want it to do both a message box and print in these two cells. So I commented out message box, so it will ignore that line. Anything that's in green, it's ignoring that. That's there so you can write, little notes to yourself to remind yourself what this is going to do. Now, arrays, we've already discussed what does it mean by array in VBA? An array can have as many dimensions as you want, although in practical terms, you'll almost certainly end up using either a one-dimensional array, which is a vector, and then a two-dimensional array is what we know as a matrix. Okay. I don't think there's a name there. Maybe there's a name for the others, but I don't know what it is. Like a three-dimensional array. I'm not sure what that would be all about, but one-dimensional is a vector, two-dimensional is a matrix. Now, of course, as you can imagine, matrices are more complicated, or arrays are more complicated than individual variables. We have to be careful about the way we fill the arrays and index them. So, of course, we know what a matrix is. It's an object that contains rows and columns, and so an array variable can have at least one dimension, but it can have more than two as well. Now, arrays, because they can have different amounts of information attached to them, we lose a lot of our normal flexibility. In other words, if you really mean for a variable to be an array, it's not enough to leave it as a variant variable. you have to specifically tell it that this is meant to be an array. And eventually, you have to tell it what the dimensions are. Okay, not necessarily right up front, but you do eventually have to get around to saying, well, listen, this is a vector or one-dimensional array with 5 elements in it, or in other words, a 1 by 5 row vector. And if it's a matrix, of course, you have to tell it the number of rows and the number of columns. That's how it knows how much storage space it needs. If you mess around with this, you could do some terrible damage to your to the VBA program itself. So it's designed to make sure you don't do something you shouldn't, like erase the program or something like that. So you do have to make sure you tell it this is an array, and here's how many dimensions I want. You can also tell it what type the variables are. You can say these must be integers, for example. They may be single precision, they may be letters, but as always, that part is optional. Now, you also have to have an index to keep track of all the elements. Typically, it'll be an integer. And like I was saying the other day, it doesn't have to start at 1, 1, 2, 3, 4, 5, etc. Your index can literally be anything, although it's restricted to being an integer. It could actually be negative, and it could be 0. All right, so here you go. How would one create a one-dimensional array? Okay, so here it is, dim, which means define. The results is your array, and it contains elements 1 through 5. Okay, so what you basically have here is something like this. And you will assign to it a value. Or actually one variable, one value for each of these elements. Okay, so let's say this, it says these are integers. So now you would tell it that the numbers you actually want in there could be, for example, 2, 3, 4, 7, and 9. So you would assign those with a separate statement. But the most important thing is you've set aside storage space for a vector of 5 elements. You can instead, you could start with 0, 1, 2, 3, 4. It doesn't care. You could have -1, 0, 1, 2, 3, whatever works. Okay, this is unusual. Most programming languages don't allow this. They usually force you to start at 1, or maybe they'll allow a 0, but they're not likely to give you negative indexes. It's just not that common. Now, option base. This is one of those keywords that they put in there it's designed to help you make sure you're being consistent, basically. Let's say, for example, you're worried that you're going to be inconsistent with the way you assign indexes to your arrays. If you type in the words option base, then it will insist that all of your indexes start with a 1. Okay, it'll say if you try to use a 0, it'll stop you. So it's sort of like a way of making sure you don't do something that you don't want to do. Okay, it's almost like it's like an alarm saying, "Listen, look what you did. You put a 0 in there when you shouldn't have." Okay. Now, here's an interesting twist. Sometimes when you create a variable like this, results, what if you don't know until later in the program how many results you'll actually have, depending on what you're doing? You don't have to tell it right up front how many elements are going to be in your array. You can wait until you've done some other calculations and then tell it what the actual results are. This is something that's very unusual. Most languages insist that you tell it right up front how big your arrays will be. So when you do this, if you do this, and we will see some examples of this, we're going to use a statement called redim, which basically says, all right, I finally figured out. So I start here, I don't know how many elements are in my results vector. Once you figure it out, this is what you tell it. You say, now that I've figured it out, I mean 1 through 5. And it says, okay, fine. We'll assign 5 spaces of storage for you, 5 bytes of storage, and we'll be happy. Okay. It's just the idea that you can wait a while until you've come up with other calculations. It's kind of unusual. Now, two-dimensional array, of course, you need 2 indexes, which we usually in math, we call these I and J. Okay. So, you don't have to call them I and J, but we often do. So here, this is a 3 by 3 matrix. I'm just filling in the row and the column numbers. Okay, so it's a 3 by 3 square matrix. Although it's called an array, of course, it is a matrix. And this is what it would look like. So in other words, if I want to say to it, listen, tell me what you find in this cell, you would refer to it as my array 3, 2. And of course, it uses the traditional matrix notation, rows and columns. Okay. Or you can do it the other way around. You can assign values to the matrix by saying, for example, my array 3, 2 equals 3, and it'll put a 3 in that cell. Or, like if you wanted to read it out, you could say, for example, x equals and then ask it to print x. And what that means is it's reading to you whatever information it finds in cell 3, 2. Now, functions. I did mention this before. VBA has a handful of its own functions. Most of the time, we'll actually be using Excel functions. But there are some cases where both VBA and Excel has the same function, and the naming conventions, of course, are different. So in those cases, we have to be careful to use the VBA functions. Like, now here's some examples. Apps for absolute, log. This is, by the way, natural log. In Excel, that would be spelled ln. Rand, for random number between 0 and 1. This is taken from the uniform distribution. And then SQR, the square root. In Excel, that would be spelled SQRT. All right, now, what about all the other ones? What about the functions that are in Excel but are not in VBA? You have to call them. You have to make sure it knows that you're asking for VBA functions. So what you have to do in order to make it clear to the program that this is an Excel function, you have to use the keyword application before the name of the function. So for example, what if you need to calculate a geometric mean? Excel has this function, which is called geomean, but it's not found in VBA. So in order to use it, you would have to type right here, application.geomean. Okay, if you leave this out, it'll look in the library for VBA functions and it'll say, oh, I don't see it there. And it will stop and give you an error message. This is how it knows to go look in Excel's library and find that function. Okay, so these are the quirky little things that you have to get used to when you learn VBA, because it's sort of like, you're using both Excel and VBA at the same time, but you have to be careful. They each have their own territory, let's say. All right, now we have the normal mathematical operators here. Of course, multiplication, we don't use an X for that. We use the asterisk. This is just what Excel does. And these are exactly what you'd expect. Okay, these are logical operators. Except here, this one you might have been surprised by. Exponentiation is this caret symbol. This is called concatenation. You normally use this to combine two things. Okay. It's the actual name of this. You don't see this very often anymore. The formal name is ampersand. It's used to represent and the idea of two things, one and the other. So, for example, let's say that I've assigned to the variable first name John. These are both string variables, by the way. In VBA and Excel, we call these string variables. And by putting out first name and blank and last name equals John Smith. In other words, what you're telling either VBA or Excel to do is combine this string with a blank space and this string, and it will come out correctly. Okay, so in other words, you're not using the English word and, you're not using any other symbols, you're using the ampersand. Okay, now what about these guys? Now, this is Boolean algebra, basically. You're looking at not, and, or, and exclusive or. Sometimes this can come in handy if you're testing a condition, is this true or is it false? Or if you want to know if one of two things is true, or it can simplify the coding if you can test two or three ideas at the same time, or something like this not. Like, for example, if you want to make sure that your variable is not negative, you can ask it, not less than 0 or something like that. So in other words, here's my statement. If X is strictly greater than 100 and Y is strictly less than 100, then Z is defined as 0. Now, this is only going to happen if these are both true. And by the way, if you notice, we're not using the ampersand. That's really meant for string operators. Okay. Here we use the logical and, which means both conditions must be true. Or means exactly what you would expect. If either X is greater than 100 or Y is less than 100 or both, then Z is equal to 0. XOR means one or the other, but not both. Okay. It has to be one or the other, exclusive or. And here, for example, not X is greater than 100. It's the same thing, of course. It's just saying, it's like in English, you try to avoid having too many negatives to make sure your sentences are clear. Uh, there might be times when it's easier to call it a not, but it's good to know that this is there for us if we need it. And then we're not going to see this very often, but we have text functions, all kinds of things, like if you have a string of characters and you want to look for a particular character in that string or part of the string, you can have the left X characters in the string, the right X characters in the string, the mid X characters. For example, cell 1 contains the phrase garden hose. So we need to define that as a string, by the way. And my string equals left A16 means starting in cell A1, copy the first 6 letters into my string. Okay, in other words, it's only taking these. If I took the last 4, then it's going to be hose. And you've got all kinds of features that you could use that might be helpful. For example, here's a subroutine uppercase. Item is a string variable. We're going to read it in from cell A1. All right, let's go get this one. Now, here's the thing, though. You've got to make sure there's something in A1 for it to work with. So let's go to the spreadsheet. And well, there it is. It's sales tax. Let's just leave it like that. Let's see what happens. All right. So it's saying um, item is range. So now the variable item contains whatever's in the cell, as long as it's a string. And it says range A1 offset 0, comma 1. That means 0 rows, 1 column. So in other words, what it's doing is it's saying whatever your results are, put it 1 column to the right of where you find this variable. And here's the function new case. And I'm sure you can figure out what that does. So why don't we run this macro, uppercase, and voila, it's all uppercase. Okay. Now, I don't know if Excel has new case. No, it doesn't seem to be there. That must be one of those functions that's in VBA only. That's very rare. Okay. You don't see a whole lot of those functions. Um, yeah, I think it's possible to go on the internet and look at a list of all the variables or the functions rather that are in both VBA and Excel. It might be handy to have one of those in front of us, but UCase clearly is a VBA function because otherwise we would need the keyword application here. And this is the other way. See, it's the exact same program, except it turns it into lowercase. So let's check that out. Number 7. What do you know? It works. Okay. All right then. So now that we've got some idea of the basic elements of VBA, we're going to look at what are called control structures, which are ways of repeating commands in a very efficient way. Uh, So let's get into now. This is where it gets a little bit more involved. Control statements. Every programming language has what are called control statements. They're designed to make things easier for us by making it possible to repeat commands until certain conditions are met. They will execute a little differently. There's certain ones that we'll use all the time, and some that we'll almost never use. So let me just show you a quick list of the ones that are available to us. And what we want to know what they're for and when they're used. Okay. The one that will really never use is go to. This is a holdover. I mean, remember, this language is quite old and it is based on even older languages. So go to is sort of an anachronism, I guess we could call it. But these others, if then means if something is true, then do this or that, depending on whether it's true or false. For next is a way of going through what's called a loop, where we say, for example, do the following command 10 times or something along those lines. Do until means do the following statements until a certain condition is met. Do while means do repeat the commands until a certain condition is true. And then select case, it's basically a way of saying, listen, depending on the circumstances, do one of the following things. It's a good way of writing programs when you have many choices available to you. We'll see an example of this in a few minutes. So, all right, we'll start with if then. So this is one of those cases where we're going to say, if this condition is true, then do the following, otherwise do this other alternative. For example, if X is less than 10, then Y is 100. And by the way, if you notice, it needs this end if statement. If you type in if, though, it will fill this in for you. So basically, What this is saying here is that if x is strictly less than 10, it'll assign 100 to y. But if you notice, it doesn't say what to do otherwise, and so therefore nothing will happen. Okay, nothing. All right, so that means it's either y equals 100 or nothing. But sometimes it can be more complicated than this. We now are introducing this keyword else if, which specifies what we need to do if our condition is false. Here's a quick example. Suppose that the property tax on a house is $5,000 if the house is worth 200,000 or less, and 7,500 if the house is worth more than 200,000. Here's how we figure out the appropriate property tax. Okay, well, first, if you notice, it's a function. Okay, because we're only producing one number, and we may as well use a function. We have to specify what information is read into the program, and that is the price of our house. Okay, you notice how we have chosen to also define it as a single precision variable because the price has dollars and cents. So we don't want to just restrict this to an integer. And here's the function. If the price that I've just read into this program is less than or equal to 200,000, then property tax, the name of the function, will be assigned $5,000. Else, property tax will be 7,500. End if. Now this works fine because those are the only two possibilities. It's either less than or equal to 200,000 or it is not. And function. Now before, when we left this part out, if we did it the same way, what would have happened is the property tax for houses worth more than 200,000 would have been uncalculated. It would have done nothing. Here it says, listen, if that's condition is false, do this instead. Okay, this works great when there's a condition that can only be true or false. If there's three possibilities, we can still use this type of approach, but it just gets a little messier. Okay, so it's not restricted to yes or no, but this is what it's good at. Actually, you may as well run this thing and see how it works. So this is number 8. So now, of course, because this is a function, I have to actually go into the spreadsheet and type, let's say that the property value, we can do this twice. This house is only worth 150,000 and this house is worth 200,000, 220, let's say. So I'm going to type, actually, let's do something a little different here. Okay, so I put equals there, you can look for it. There it is. And all I need is to tell it, oh, the property value is right here. Good. And so by doing it that way, I can just drag this down. It'll tell me what the property tax is. And in fact, if I have a huge column, let's say I'm looking at 1,000 houses in a small city, this won't take that long because all I have to do is drag this down and there'll be one for each house. So it's very efficient. Well, that's nice. Okay, so I add another house, 300,000, no problem. Oh, there you go. Now, of course, what if I decide, oh, I goof, this one is really worth 320,000? No problem. It'll update itself automatically. That's, by the way, that's not true with the subroutine. You have to run the macro all over again. Okay, well, that was interesting. Oh, sorry, I'm the wrong one. What else do we have here? Okay, well, this one is similar to the previous one where we only have one possible outcome. If X is negative, then the variable will, this, by the way, this one is returning a string variable. It's going to be negative number. And once again, it has to be in quotes. So if you run number 9, um, uh, let's say this is X. I'm going to run this or run this function equals sign result of this value. And oh, you know what I bet I did? I missed this part. Whoops, I didn't even realize that was there. So this one is even more complicated because we're allowing for 3 possibilities. How did we pull that off? Okay, well, if X is negative, fine. Sign result is negative number. But because there's 2 more possibilities, instead of using else, we're going to use else if, and we're basically starting with a brand new if statement here. So now if X is 0, then the sign result is 0. Else, the only final other possibility is positive rather, and that's what we see here. So in other words, in order to have more than 2 conditions, we need this else if statement. So what you're effectively doing is starting a new if statement. And because of that, we can in principle have as many ifs and else's as we want. But when you get past a certain point, then we're going to instead use this, the last one I mentioned here, select case. Select case is good for when we have like many possibilities. Like what if there were, let's say, going back to the property tax, what if there are potentially up to, let's say, 8 different property taxes? Then using if else is going to get very clumsy very quickly. So then select case would be a much better choice. Okay. So anyway, so you're starting to get a feel for how powerful these statements are. We can do a lot with these. So for example, let's look at this one. Number 10. We're going to figure out everyone's letter grade based on their average score in their exams. So we read in a grade, and I'm going to follow along here. Just close this one out. And I'm going to go to Excel. So I'm just going to randomly pick a bunch of numbers. Okay, so what it's saying is this. If the average is strictly less than 60, you get an F. If it's greater than or equal to 60 and which strictly less than 70, we get a D. Once we get into this range, 70 up to, but not including 80 is a C. 80 up to 90, not including 90 is a B, else my grade equals A. Now, if you notice, this last else has a colon here. This is the kind of thing that we have to learn. It's easy to overlook it. When we have a bunch of these else ifs, we wrap it up with one final else, which is the last condition. Now, end if, oh, by the way, yes, end if, anytime you use an if, we need to have a matching end if statement. And of course, don't forget with a function, you have to have the end function. So if I type in my grade, you'll see it works very well. Okay, assuming that these are the correct grades. But if you notice, this time we allowed for 5 different grades. And so, yeah, this may not be the ideal way to set this up. Well, when we get to the case select, we'll see that that might have been the better way to go. But it certainly can have any number of conditions that we can imagine. Now, for next, this is when something needs to be repeated potentially many, many times. We're going to create what's called a loop. Okay. Now, for next is used for cases when we know how many times to run through that loop. Here's a good one. Function counter, n as integer. So n is being read in. Dim sum. Now, sum is defined internally to this function. If you notice, there's no mention of sum outside of this program. It is an internal variable, which will be an integer, and we'll use it to come up with a sum of whatever numbers go into this program. And then that sum will be sent back to the program. But if you notice, we have to make sure that we call the result counter because that's the same as the name of the function. If you try to put send back the sum, it won't know what you mean. You have to make sure sum is assigned to counter. That's how it knows to send that back to the Excel spreadsheet. Now, if you notice, we have our first loop here. So let's say I tell it that n is 10. That means I want it to add up the first 10 integers. And if you notice, the loop will run it will go for x equals 1, 2, 3, 4, 5, all the way up to n. So n is a variable. Okay. It's not a constant, it's a variable. So this loop could get very long. And what we're doing is we start by zeroing out the sum, and we get into the loop. For every number, we add that to the existing sum. And then when we're done, and by the way, this next is mandatory for 4. That's how it knows to go to the next loop. Okay. When you're done, whatever the sum is what we want to send back to the program. So let's run this with, let's say 5. We're calling this counter. All right. So in other words, what it did was it added up 1 through 5. Huh. Now, by the way, how can you do a quick check to make sure this is working correctly? It turns out that when you have a sum of consecutive integers like this, then the sum is going to be n plus 1 over 2. So I'm going to put that in a separate column just to prove it. Yeah, let's get this out of here. So I'm going to have n times n plus 1 over 2. Whoops. Yeah, what do you know? So yeah, there's a lot of these cool formulas you can come up with. Um, any calculus book will have a list of them at the back somewhere. Although this is the kind of thing you're likely to run into in a computer science course, but you know, they can come in handy. Okay, so anyway, so that's what this is doing. Now, what if I don't want the index to go up one at a time? What if I only want every other one? Like 1, 3, and 5, for example. Then what I do is I add this extra keyword here, step. Okay. So what this means is that instead of executing the indices 1, 2, 3, 4, 5, it's going to go 1, 3, and 5. Okay. So now here's a really interesting feature. We can go backwards. We can go 5 down to 1 by using this command step -1. So sometimes you might want to go the other way around. And so there it is. You just have to remember to use the word step. Interesting. But if you notice here, we did not use the word step. By default, step is equal to 1. It would go right here if you wanted to change it. Okay. So if not, then you would use that step command. Now, here's a twist. Now, this is where it starts to get really interesting. You can have one loop inside of another loop, and you normally use these to fill in a matrix or two-dimensional array. In other words, you're going to say, listen, go through and fill in all the columns, but within each column, fill in all the rows. Okay, so you can go from column 1, row 1 through 5, column 2, 1 through 5, et cetera, et cetera. So we're going to see some very interesting examples of this. So this is where it starts to get just a little more intense. So I'd like to save this one for our next meeting. Um, yeah, I mean, this is all getting to be a bit much, I think, but once you start writing the programs, you'll see how straightforward this can be. But there's still certain things we have to know about the language because it can be very quirky. So this what we're about to do is so important that I'd like to save it for the next session and start with that and run through an example from start to finish. Okay, because it's awfully, awfully important. So anyway, I think we've had enough VBA for one day, and I'll see you all next time.